So let's dive into today's work. Yeah, the question says, if 4 times 75 degree all over 1 minus tan square 75 degree equal to 1 all over 150 degree, find tan 75 degree in solid form. So how do we take this? We take our solution. Let's write out our equation. So we have 4 tan 75 degree all over 1 minus tan square 75 degree again, all equal to 1 all over cos 150 degree. All right, now that we have the number one thing we do is to hold the left hand side of the equation and deal with the right hand side. So let's take our right hand side of the equation, which says 1 all over cos 150 degree is equal to 1 all over, take a look at this 150 degree. If we draw our 4 cardinal point, which is our quadrant, so this is your first quadrant, this is your second quadrant, and your 150 degree falls into the second quadrant. The manipulation in the second quadrant is 180 minus the value of theta given. So the value of theta given here is 150. So we now do 180 degree minus 150 degree. This will give us 30 degree. Mind you, cos theta in second quadrant is minus. We have sine positive, tan positive, but cos is minus. So hence this will become minus cos 30 degree. All right, now that we have this, we can proceed. This is equivalent to 1 all over, we put our minus sign here. What is cos 30 degree? From our special angle, cos 30 degree is root 3 all over 2. So we equally replace this with root 3 all over 2. Now, because of this one we have here and this division sign, if we manipulate this, this could also be written as 2 all over root 3. We have this in standard form already. What do we do? Let's bring this left hand side to marry it with this other side. So this now implies that 4 tan 75 degree all over 1 minus tan 70 tan square 75 degree equal to minus 2 all over root 3. Let's remove this 4 by dividing both the left hand side and the right hand side by 4. Here, divide both sides by 4. So if we divide both sides by 4, automatically this is going to give us tan 75 degree all over 1 minus tan square 75 degree, or equal to, if you divide this side of the equation by 4, you're going to be left with minus 1 all over 2 root 3. All right, now that we have this, we can cross multiply. So if we cross multiply, let me show this with an arrow movement. So this we multiply this we go into this. So if we cross multiply, 1 we multiply the whole of this. So this will give us 1 minus tan square 75 degree equal to, if we use this to multiply this alongside with the minus sign, this will give us minus tan 75 degree times 2 root 3. So if we simplify this further, this will give us 1 minus tan square 75 degree equal to minus 2 root 3 tan 75 degree. Now, take a look at this. We can rearrange this system. So if we rearrange this will give us tan square 75 degree. When we send this to this side, it's going to give us tan 75 degree minus 2 root 3 tan 75 degree. Then bring this to this other side, it gives you minus 1 or equal to 0. Now, if you take a critical look at this, you will discover that this is a quadratic equation. But how do we now bring down the quadratic equation out? Then we can say here, let tan 75 degree be equal to x. So wherever we see tan 75 degree, we put in x into that place. So we proceed again. This will now give us x squared minus 2 root 3 on in x minus 1 equal to 0. Very easy now. You can now see the true picture of the quadratic equation I told you of. Now that we have this now, let's quickly go into factorizing this or solving this using the quadratic formula. Now, there is a video I have produced on how to derive the quadratic formula. It's up here, showing here, okay? You can watch this video to know how to derive this quadratic formula in case you forgot the formula in an exam hall. All right, so you can watch it. Now, let's bring in our quadratic formula. Our quadratic formula says that minus b plus minus the square root of b squared minus 4ac all over 2a. The next question we ask ourselves, what is the value of b? What is the value of a? And what is the value of c? From our quadratic equation, we can bring out these things. So from here, we have our a is equal to, a is the coefficient of your x squared. The coefficient of x squared here is invisible plus 1. So we have plus 1. B is the coefficient of x. So the coefficient here is minus 2 root 3. And c automatically is the constant term. And the constant term here is minus 1. So let's go ahead and put these values into this quadratic formula. Very easy. So this now implies our x will now be equal to minus this minus that is existing, then bracket b is minus 2 root 3, close the bracket, plus minus, then square root b square is minus 2 root 3 all squared minus 4 into our a is plus 1 and our c is minus 1 all over 2 into plus 1. Okay, very easy now. So from here, let's simplify. This will now give us minus times plus will give us, minus times minus will give us plus. So here we are left with 2 root 3 plus minus. Then here we have our square root. What is the square of minus 2 times minus 2 root 3 times minus 2 root 3? Of course, that will give us 12. Minus times minus will give us plus. Then 1 times 4 times 1 will give us 4. All over 2. Because 2 times 1 will give us. So from here, we now have. So if we have to proceed, then we add the terms inside the square bracket. So if we add up, this will give us 2 root 3 plus minus root 16, because 12 plus 4 will give us 16 all over 2. Then let's fire down again. 2 root 3 plus minus root 16 is 4, because 16 is a perfect square. So here we put here 4 all over 2. All right, so let's proceed again. We go ahead to factorize these two signs we're having here now. But before we do that, 2 is common here, 2 is common here. So we can factorize 2 out. So if we do that, this will give us 2 bracket root 3 plus minus 2 close bracket all over 2. You get that? Now, these two at the top can go with these two at the bottom. So we are now left with root 3 plus minus 2. All right. We can now go ahead to factorize, to simplify these two signs. So let's simplify that and say, so this will now give us root 3 plus 2 or root 3 minus 2. But recall, your cos 75 degree is going to fall under the first quadrant, and cos 75 in the first quadrant is positive, and the second answer here is going to give us negative answer. So this is out of the system. We take the positive one. Thus, we can now say, therefore, x is equal to root 3 plus 2. But let's go back to this part of the equation. When we were solving, we said let tan 75 degree is equal to x. And that is what we are looking for. So we can now say, therefore, x is equal to tan 75 degree is equal to root 3 plus 2. This is the solution to this problem, this simplification here. All right. So if you have any question with regards to this solving, to this challenge, drop it in the comment section. And at the same time, if you are gaining value from our videos, also drop it in the comment section by giving our videos a like and a thumbs up. All right. Remember, in Online Maths TV, we love you. Jigs loves you. Thanks for being there.